Hi guys, my name is Yenisbel Hernandez. We're going to cover the 4th edition task list, section H, or part of section H. And we're a study group called ABA Exam Academy. The disclaimer is the following. The BCBA Exam Prep Study Group was created by and for students to earn their BCBA or BCABA certification. Most of the leaders and participants are not a BCBA or BCABA at this time. These meetings are meant to have active discussions, to collaborate, ask questions, and provide helpful suggestions to better understand the BACB 4th edition task list concepts. Due to this, it is important to know that all viewers and participants are responsible to verify the accuracy of the information being provided in order to successfully prepare for the BCBA, BCABA exam. Ethical considerations, please remember, especially those of us who recently took the test, to refrain from sharing any BCBA or BCABA test questions during this meeting. Also from sharing any paid resources or specific identifiable client information during the meeting. And sharing, if we're gonna share any open resources, peer review articles or books or any other information, which we always do, always give credit to the author. And the guidelines for the book, just for everything to go smoothly, professionally, and ethically, are the following. Make sure to mute your microphones if you're not speaking. This will allow us to hear better and to understand better. And remember, we're recording, so turn off your cameras if you don't wish to be recorded. Allow the leaders and all participants to turn to speak without interruptions. Make sure to be respectful to others and refrain from using any inappropriate language throughout the entire meeting. And let's have fun. So today, Demi did a really good job yesterday. Today I wanted to do a quick review so we can just work on fluency. And for those of us who still not that very fluent with it, then refresh it. Now we're going to begin to start like different levels. People that have been studying intensively for 5 months, and if the people that are only studying for 3 months, then we're going to try to cater to everybody. So I strictly focus on Cooper and Mayer, and the questions are created by me. So 5 ABA graphs, guys. Ready, set, go.
Line graph.
Line graph.
Standard acceleration.
Standard acceleration and bar graphs, right? Did anybody else say anything else?
Cumulative record.
Cumulative record, good. Are we missing one?
Semi-logarithmic. I can't even say it right.
Semi-logarithmic.
Histogram.
The histogram, which is the same as which one?
As your favorite.
Bar.
graph.
Bar graphs. Nice job, guys. If I don't, my whole system is having issues today. Everybody sounds super mellow and low, and you guys sound very decent, not loud at all, which I'm not used to because I like the loudness. So speak up. Feel free to speak up too. Okay, line graph, bar graph, cumulative records, Scatterplot, semi-logarithmic charts, which also includes standard acceleration charts. Are they AKAs, guys?
No.
No. What are they?
Standard acceleration chart goes under. That's a type of graph, semi-logarithmic, right?
So semi-logarithmic charts is basically the umbrella. That one has different charts or graphs or something like that. And then under the semi-logarithmic goes the standard acceleration charts. So basically, standard acceleration is one of the semi-logarithmic charts. And we're going to go more over it later on. Okay. So now, AKA for line graph. You guys know this. So ready, set, go. Oh my God, you're so loud.
Polygon.
What?
Frequency polygon.
Frequency polygon, yeah.
Okay, got it. Frequency polygon. And AKA for bar graph, the Martin already said it a while back.
Histogram.
Histogram. Okay, and the other one is semi-logarithmic charts. Okay, remember, cumulative records doesn't have AKAs, Scatterplots doesn't have AKAs, and standard acceleration doesn't have AKAs. As far as I know from the research that I found. You know how it is. Tomorrow they do a new study and they make up a new AKA. But as far as I know, this is what we have. Semi-logarithmic charts. You remember the AKAs?
It's multiply, divide. Is that it?
It's multiply, divide, yes.
And the other one?
The other one is ratio chart.
There you go, Martin. You got it.
Oh, good job.
Nice job, Martin. Okay, so yeah, multiple divide charts and ratio charts. I think that by the end of this week, we're gonna learn those AKAs. We're gonna have them for real. So this is fast. This is for fluency. This one is the first one.
Line graph.
The second one.
Bar.
The third one.
What is it say there? Cumulative record.
Cumulative record.
That's
and this one is the one that I always get sometimes. I used to get confused. Now I'm getting much better at it. Which one is this one? Demi did really good yesterday at explaining it.
Scatterplot.
Scatterplot. The other one?
Standard acceleration.
Standard acceleration. Semi-logarithmic, it's under standard acceleration, which is a type of semi-logarithmic charts. Okay. So now we're gonna go to the more difficult part, or the more detailed, I guess. So from what I found in the research, the 5 ABA graphs are divided into 2 main groups: equal interval graphs or non-equal interval graphs. The equal interval graphs. Does anybody wants to explain what's the difference between them? One of the non-equal interval graphs is semi-logarithmic charts. So that should give you a hint. Remember about the AKAs.
Line is a equal interval graph.
Yes.
I think it's because in the x-axis and the y-axis is divided equally, like in multiples, I guess. In the multiple goes into semi-logarithmic, but you were good until you said divided equally. There,
yeah.
Let's go for it.
It is divided equally, but it's not in multiples.
Yes.
It's the same amount. So if it's 10, it would be 10, 20, 30, 40, 50.
Okay.
Yes. So the multiple goes to the non-equal interval graphs. But this one, you're going to learn it now when you learn the AKAs. This is why this one, the AKAs makes total sense to me. And it's important for us to learn them, because once we learn the AKAs, then it's much easier for us to remember what they mean. So here's the visual that David gave us yesterday. Remember, this one belongs to equal interval graphs. And this one right here belongs to non-equal interval graphs, which is a semi-logarithmic chart. Let's go for the official definition from Cooper. It says that graphs, the equal interval graphs, are graphs in which the distance between any 2 consecutive points on both the x-axis and y-axis, it's always the same, which is, in simple words, what Minerva said, right? They're the same. Same distance. All intervals are the same size, and this is that's all they have for this one. And for non-equal interval graphs, which is the semi-logarithmic charts, it says that it looks at behavior change through proportional or relative change. Let me move this thing. All behavior changes of equal proportion are shown by equal vertical distance on the vertical. Does anybody else want to explain it in their own words? Okay, so basically it's proportional. It's if I'm gonna give you the example, okay? Oh, the other tip is graphs in which one axis is scaled proportionally. And the example is a doubling of response rate from 4 to 8 responses per minute would appear on a semi-logarithmic chart or non-pointer graphs as the same amount of change as a doubling from 50 to 100. So here in the, you see it's 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and so on and so forth. So if the child got 2 right, then the next day he got 2, and then he got 2 times 2 would be 4. So it goes into multiples, and that's where the AKAs make sense here. And this one, it multiplies or divides, which is going down. And in the equal intervals, the AKAs are?
Add, subtract.
Add, subtract. So it's adding, going up, or subtracting, going down. So you can see that it's obviously adding 10. If we're still a little bit confused, we're gonna go to the next one. It's gonna help her explain better. I like Mayer's explanation much better than Cooper. He put it more in and I wrote almost word by word. I just changed the ladito with the names. So I'm gonna read it, okay? Imagine increasing a student Albert's accurate responding from 2 to 4 correct answers per day, and student Bob from 10 to 20, right? If you plotted these on standard linear graphs, a student Albert's improvement of only 2 correct answers that day would seem small compared to students Bob's improvement of 10. So one child, let's say on Tuesday, you taught the information on Monday. On Tuesday, you tested them. Albert got 2 more correct on Tuesday, and Bob got 10 more correct. Obviously, if you plot that in a equal interval graph, it would look like which student has learned more. The student that got 10 or the student got 2 correct?
The one that got 2?
Which student do you think would look like learned the most? The student that got 2 correct or the student that got 10 correct?
Obviously 10 correct.
Exactly, right? Because that's you're just going with common sense, with what is the basic. Adding, which is the equal logarithmic one. But in terms of percentage, both students improved by 100% as a result of your teaching. So basically, if the student started with 10 and the next day he learned 10 more, it just means that he learned, and then the other day he learned 10 more, it just means that he's moving at a consistent rate, right? From 10 to 10 to 10 to 10. And the same thing goes with a student that started with 2 and then he moves to 2 more and 2 more. So he's also moving in a consistent rate. So that's basically showing that while you're teaching them, the skill that you're using is still working for both of them because they're still improving. It's just Bob is improving at his level and Albert is improving at another level. But they're equally, in terms of rate, they're the same. Does it make more sense now, or am I just confusing you more?
No.
No, doesn't make any sense. Okay, let's put the numbers in, guys. So I think I put in Albert's information first. So the first day, Albert got 2. We're gonna put it first in in this one first. That's the equal interval charts, right?
Yes.
Okay, so where do I put it? I need to put in 2 first. So where would I put it?
On the first line and 2.
And 2, right? And then I need to put 4. So I would put it here and
There.
4.
here. Okay, there you go. And now I'm gonna plug in Bob, which is 10 and 20. So 10 and 20. I had to add it out. I just left it like that so we can have a visual representation. So we're gonna plug in the next one, which is, this is the non-equal logarithmic one. No. Okay. It's 2 and 4, and then the same, it's 10 and 20. So this is the same thing happened in the one that they had in Cooper. You see the big jump, and here the big jump. So when they change it to rate, it looks like the learning is the same. But here it looks that the learning, it just jumped up.
Right.
Okay, so basically that's it.
Mm-hmm.
So I just did a visual representation of how it would look with the example from Mayer. And you can see the example that I left on it, it was from Cooper. It still has the same concept. Can you see the same concept? Yes?
Yeah.
Perfect.
Yes.
Yes.
Okay, so what did I do? Why did I do a circle here and a triangle here?
To represent 2 different people.
Yeah, so I did it right? So did I do the line correct or incorrect? According to the way we're supposed to graph.
Well, it needs to be in black.
It needs to be in black, that's right. So that's what I wanted you to see. It needs to be in black. I just did it like that to show it. Okay, so from this one, we're just gonna see which one are equal interval graphs. I kept saying the name wrong, I think. It's equal interval graphs, and which one is a non-equal interval graph. So which one are the equal interval graphs? Okay, I'm gonna give it to you. Line graph.
1, 2, and 3.
It's doing, you just gotta remember that equal interval graphs, they're adding, they're not multiplying. That's all you gotta remember. Bar graphs.
And cumulative record.
Cumulative records, which other? Scatterplot.
Scatterplot.
And the only one that is non-equal interval graphs is the semi-logarithmic chart or standard acceleration charts. That's all you gotta know.
Okay.
Basically, in the test, just look at it and think, is it adding it or is it multiplying? If it's adding in the y-axis, then it's the equal interval graphs. If it's multiplying, it's non-equal interval graphs.
Mm-hmm.
Okay, the AKAs for equal interval graphs, I know it's annoying, but they're gonna, when they put the mocks, they mix up all of these words. That's why I keep
saying it to see if we can associate it and be fluent with it. So anybody remembers what the interval for equal interval graphs is? The AKA for equal interval graphs?
Add, subtract.
Is it
Add and
equal,
subtract.
equal interval graph is arithmetic?
It's arithmetic and add up subtract. And that's what I kept talking about, right? The add and subtract one. And the AKA for semi-logarithmic charts, there's no, like I said, there's no, I didn't find any AKAs for standard acceleration charts. That one we already talked about it, remember?
Multiply, divide chart and ratio chart.
Yes, and ratio charts. Okay, all of the following are ABA graphs except A is line graphs, B is bar graphs, cumulation records, a scatterplot, or standard acceleration chart.
C.
C, cumulative record.
Cumulation records, not cumulative.
C. Yeah.
Nice job. Yes,
C.
because it's spelled cumulative records, which doesn't exist. And they do that on the mocks. Okay, I'm studying for the BCBA and I want to graph the number of hours I study each day. What type of graph should I use? Line graph, bar graph, cumulative record, scatter plot, standard acceleration chart.
C.
Guys, I'm sorry, I can barely hear you. Are you talking?
They
C.
said C, as in cat.
Okay. C?
Yeah.
Yeah, you're right. Most common graph in ABA is that one, you know.
Line graph.
Line graph.
Nice job, guys.
The first one.
A teacher plots the number of books read per students during spring break. Which graph should she use? Line graph, bar graph, cumulative record, scatter plot, standard acceleration chart. This one's hard. I found it very hard.
A teacher with the number of books read per student. It's per student, so I would say scatter plot.
I would say bar graph.
Yeah, I was thinking bar graph too.
It's bar graph. And the reasoning that they gave is that the teacher is summarizing performance within a condition or a group of individuals. That's in Cooper. Okay, this one, oh, okay. This one, which line is this one that it's pointing at?
Y-axis.
Y-axis that has an AKA, that is what?
Vertical.
Ordinate.
Ordinate. Nice job, guys. And the line here is pointing at?
X-axis.
Abscissa.
It's an AKA for the easy ones, which is?
X-axis.
Horizontal line.
Oh.
X-axis.
An abscissa.
You guys don't have issues with this one, but I created a mini dance for myself. Let me see if I find it. I had it ready and my son took it out. So, I'm not gonna dance. Yes, I am. Oh God. So what I did is I tried different stuff, but nothing worked. And what I did a couple of days before the exam, I just created my mini dance. Okay, ready? Vertical line, y-axis, ordinate.
It cannot be anything else. Vertical line, y-axis, ordinate. Now, ready? Horizontal line, x-axis, abscissa.
I can just see it in the extended recording you going.
Abscissa. There you go.
I love it. I love it.
Did you see it? Because I cannot see myself. Thank God.
Yeah.
Do you know
You
the
were-
camera is like right in your face when you're testing, right? You can just see it. My arms going, what?
What?
It'd be
What can you see? I don't know.
fun.
Did you see the hands?
Yeah, everything.
Oh, okay.
Yeah, that was funny.
Okay, so you're not going to forget it. And the thing is that when you do the horizontal, the X and the A, there's no way that you can do the O. So there's no mixing them up. So if you're having trouble with that one, just do the dance. I went to the test doing like that.
That's funny. I love it.
They didn't kick me out, so that's good. So I want to graph the percentage of trials in which 6 children picked up different toy items during a reinforcer assessment. Is it line graph, bar graph, cumulative record, Scatterplot, standard acceleration chart? I also found this one to be difficult.
Is that one scatter plot?
No.
No, it's
No?
gonna be standard acceleration, isn't it?
Jeez.
I'm gonna give it to you. It's also bar graph.
Oh, wow.
And the reasoning is that it's displaying separate sets of data that are not related to one another.
Hmm.
That's a
It's
Different
6 children
toys.
picked up different toy items during a reinforcer assessment. I guess the
So even
thing. Go ahead. Somebody
even
was
if they're
talking.
doing a reinforcer, yeah, even if they're doing a reinforcer assessment, just because they picked up different toys, it's considered different.
I think it's because they're doing the 6 different children. They're comparing 6 different children, which are different, right?
Okay.
So bar graph is used to find the percentage. I mean to graph the percentage.
According to what they wrote here, yes.
Okay.
You can also put the percentage of trials. Okay, use you gotta pick which one. Use blank when you want your data to effectively communicate the following relevant quantitative, oh my God, quantitative relations. Why use this? Basically, why do we use this graph and not another graph? So data that can be scaled along some dimensions, such as time or the order of responses in a sequence. For example, number of hits over time.
Scatterplot.
So we have one for Scatterplot. Anybody else?
Is this standard acceleration?
No, let's read it again, guys. I think it's, I didn't memorize this. So data that can be scaled along some dimension, such as time, or the order of responses in a sequence. I think it's
someone in the chat put line.
Yeah, okay, good. I'm glad. So
I did. I said
I
line.
really think that we need to memorize this stuff. And the other question, I got it from the same place. Not the question, I mean the information to create the question. Okay, I forgot what I did here. Okay, so you got this one, guys. This is an easy one. This one I made it especially for fluency. Ready? Ready, set, go. This graph is called?
Scatterplot.
There you go. Okay, Use blank when you want your data to effectively communicate the following relevant quantitative relations. Basically, why do we use the graph? The graph is used for target behaviors can be measured in cumulative units. For example, numbers of words read. That should give you a tip. The target behavior only occurs once per observation period. The blank shows how rapid or slowly the target responses are repeated, and we can use it to look at our own behavior in self-management programs. Effects of the IV are easier to detect than in other graphs. Line graph, bar graph, cumulative records, scatterplot, standard acceleration chart.
Cumulative record.
The record.
So what give you the hint that it was a cumulative record, since you all said the same thing?
It only occurs once per observation period.
Self-management.
Okay, that's good.
And it's easier to detect that part also.
That one's good. Okay, guys, so to interpret the data, you must ask yourself, how consistent or regularly or irregularly is the change that is taking place? Is it level, trend, or variability? When you ask yourself that question.
Variability.
I have one for variability, right?
Yes.
Anybody else? This one was taken from Mayer, and Mayer said it exactly like this. To interpret the data, you must ask yourself, how consistent, regular, or irregular is the change that is taking place?
I would say trend. Trend.
Okay. So I have one for trend and one for variability. Which other?
I think variability too.
Variability. Okay, let's go.
Mm-hmm.
Variability.
Mm-hmm.
So it's variability. And I think the key is how consistent is the change.
Mm-hmm.
Why do you think it was variability, Minerva?
Because when you see the graph and you see the data points, it's easy to see how consistent it's from one point to the other one. And with level, you cannot see like how consistent is that. I mean, I don't know.
That's a good explanation. I like that explanation. Okay, so use the following graph when you plan when you want your data to effectively communicate the following relevant quantitative relations. Basically, why do you use the graph? So is the temporal distribution, example time of the behavior, and the grouping of the individual data points may help to identify elusive environmental stimuli. Is it line graph, bar graph, cumulative records, scatterplot, or standard acceleration chart?
Scatterplot.
Scatterplot.
Scatterplot. Why do you think it was scatterplot? We have one for scatterplot. Anybody else?
Scatterplot.
Okay, everybody thinks that. So why do you think it was scatterplot?
Because the temporal distribution.
Mm-hmm.
Yes. The temporal distribution gave it away. Okay, this is, I believe, an easy one. So I want to work on fluency. I want everybody yelling out because I'm either going deaf today or I'm having technical issues. I hope it's technical issues. Ready, set, go. AKAs for line graph.
Add, subtract.
Add, subtract chart.
AKAs for line graph. Line
Frequency
graph.
polygon. Frequency polygon.
Frequency polygon.
There you go.
Yeah. Right.
Ah.
We gotta go over all the other AKAs. They're confusing, man. Frequency polygon. Good job, Martin. You took that one.
AKOs, not AKAs. I'm just saying because they knocked me out.
Okay. Use the following, why do we use the following graph? Is to primarily when you are concerned with promoting rate of responding. This one's super easy. The more rapid and fluent the rate of correct responding, the more durable the learning. Line graph, bar graph, cumulative records, Scatterplot, standard acceleration chart. God dang it.
Standard acceleration chart.
There you go, guys.
Yep.
Standard acceleration chart. I think the only one that we truly keep having trouble with when it comes to the definition is line graph and bar graph.
Yeah, bar graph is getting to me.
Huh?
Bar graph is getting to me.
I keep reading them and, you know, I get to a limit. Like, I still don't quite understand why would we use one from the other one. I understand the definition, but I'm not fluent with it.
Right.
Okay, I have less than a minute. I forgot how many. Do you guys want to stop and start a new one?
Sure.
Hopefully I'll be